This video will allow you to practice with the distributive property. So let us consider the problem 3 times the quantity 5 plus 1. I want you to solve this problem 3 different ways. I first of all want you to use the order of operations. Secondly, I want you to use the distributive property. And the third way I want you to do it is by drawing rectangles. And your picture should convince me that you should represent using the distributive property, but should also show that the order of operations works. So pause right now and see if you can follow order of operations to get the value, and then use the distributive property to get the same value, and then draw rectangles that will give a convincing picture that either method is legitimate. I will now work out the problem by all 3 methods. So using the order of operations, we would say that this is equal to 3 times 6, which we know is 18. Using the distributive property, I would say that this is equal to 3 times 5 plus 3 times 1, which is 15, plus 3, since multiplication comes before addition. And when we add 15 plus 3, we get 18. So we get the same answer either way. Now the key is drawing the rectangles to illustrate all of this. So we can show a rectangle that is 3 units tall, and then we can start by creating a rectangle that is about 5 units wide. So I have a visualization of a 3 by 5 rectangle. Now I'm going to turn around and add on a rectangle that is 3 units tall, but only 1 unit wide. When I look at that, the first rectangle has an area of 15, corresponding to the 15 that I got from the distributive property, and the second rectangle on the right has an area of 3, corresponding to the 3. And when I add those together, I'll get a total area of 18. But it would be important to note that this side had a length of 6, corresponding to the 6 that I originally had when I followed order of operations. And if the rectangle is 3 units tall and 6 units wide, the area would also be 18. Let's do one problem that's just slightly more advanced. Let's do 3 plus 2 times the quantity 4 plus 1. Once again, solve this using order of operations. Solve this using, I should say evaluate this, using the distributive property. And then draw rectangles, which will give a convincing argument that either method is equally valid. So here is how we do it using order of operations. We do what is in parentheses first. So we add 3 plus 2 to get 5. Simultaneously, I could add what's in the second set of parentheses and get that 4 plus 1 is also 5. So now I multiply these factors together and get that 5 times 5 is 25. Now, let me do it the second way of using the distributive property. The distributive property tells me that I must multiply the 3 times both terms in the second factor. So the first thing I will do is I will say this is equal to 3 times 4 plus 3 times 1. The next thing that I need to do is multiply the 2, which is the second term in the first factor, times both terms in the second factor. So notice the first term in the first factor gets multiplied by every term in the second factor. If there were more than 2, we would just multiply it by every term. And then the second term in the first factor gets multiplied by every term in the second factor. So let me continue. So 2, we would write 2 times 4 plus 2 times 1. Now let's work these out. We have 4 different products: 12 plus 3 plus 8 plus 2. Let's continue and add these together. 12 plus 3 is 15, plus 8 is 23, plus 2 gives us a total sum of 25, just like we expected. Now let's draw this out graphically. So 3 plus 2 could be represented. Let's start right here in the bottom right-hand corner and go 3 units up, and then go approximately 2 more units. So we have 3 and then 2. And then starting down here, let's go 4 units to the right, and then let's go 1 more unit to the right. So I have a 4 and a 1. Now let's complete the rectangles. And this lower left rectangle is 3 by 4, so it has an area of 12. The upper left rectangle has an area that's 2 by 4, which gives an area of 8. And the lower right is 3 by 1, so its area is 3. Clearly things aren't quite to scale. Looks like my 1 is almost as big as my 2. And then I have a 2 by 1 area, which should give me a total area of 2 there. So some of the proportions are off, but hopefully you get the idea. What do these numbers correspond to? The 12 corresponds to the 12, the 3 to the 3. So that's where we multiplied a height of 3 times a width of 4, height of 3 times a width of 4, and a height of 3 times a width of 1. And then we multiplied a height of 2 times a width of 4 to get 8, which corresponds to that term right there. And we multiplied a height of 2 times a width of 2 and got 2, which corresponds to that term there. When we sum all of the areas, we get 25. How does that relate to the 5 times 5? Make sure that you realize the total height of the rectangle should be 5 units, and the total width of the rectangle should be 5 units. So it makes sense that the area is 25.